The EV market is now as competitive as ever, but Elon Musk and Tesla just have a way of always remaining at the top. Lithium-ion batteries are the most common power source for electric vehicles, but Tesla's new battery will surprise the entire EV industry. What's this new battery all about? Stay tuned! Welcome back to our channel. In today's video, we will be taking a look at Elon Musk and how he just launched the cheapest battery that will shock the entire EV market. Make sure to click the subscribe button so you don't miss out on any future uploads from your #1 channel about Elon Musk, Tesla, SpaceX, and much more. Let's get started. The EV sector is predicted to represent one of the largest future needs for batteries. Government policies have aided the transition from gasoline-powered automobiles to electric ones. Governments have stated their desire to minimize carbon dioxide and other heat-trapping pollutants. The lithium-ion battery is the most popular type of battery in use today. This type of battery powers everything, from cell phones to laptops and electric vehicles. Lithium-ion batteries are likely to be the most extensively utilized for electric vehicles. Tesla has always purchased cells using its own chemistry from its suppliers, but saw issues on the horizon. Tesla aspires to grow at a rate of 40 to 50% per year, and in order to do so, it will require an increasing number of batteries. Tesla's battery estimates revealed a discrepancy between its battery cell suppliers' production limits and Tesla's internal demand for its car and energy storage businesses. To address this, Tesla's team got to work purchasing and inventing new technical solutions to help the battery cell format advance further. Perhaps more importantly, Tesla used its expertise in the field of battery cell manufacturing and its world-class manufacturing equipment expertise to completely reinvent the process from start to end. The new tabless 4680 cells. The new 4680 cell's tabless architecture has a direct impact on enhancing manufacturability. The table's design eliminates the requirement for a tab and the need for production lines to pause to add tabs. The new tabless cells bypass this stumbling block, allowing a manufacturing line to hum along, rolling up and spitting out gigantic 4680 cells with fewer manufacturing defects. The new 4680 tabless cylindrical battery cell format offers a slew of performance, production, and cost advantages. As the name suggests, the new jumbo cells have a diameter of 46 millimeters and a height of 80 millimeters. The larger jelly roll fits more active battery material inside the case, increasing energy storage by 5% and power by 6%. Scaling up to the pack, the new form factor alone delivers a 16% increase in range. The new tabless 4680 cells are superior to tabbed cells in almost every manner. Even though they are larger, removing the tab makes it easier for electrons to move about inside the cell than the present 2170 cells. Musk said, "You actually have a shorter path length in a large tabless cell than you have in a smaller cell with tabs." Improved chemistry. Today, silicon is used in Tesla batteries, but its physical properties make it difficult to employ in large quantities. The problem with silicon is that it grows by 4 times when it is charged with lithium. After oxygen, silicon is the most prevalent element in the Earth's crust, making it a low-cost and easy-to-find commodity. In fact, sand is just silicon dioxide. To work around silicon's rough edges, Tesla, perhaps unsurprisingly, started with raw silicon. Right off the bat, that lowers the cost of the silicon, and Tesla simply built a new chemistry to complement it. The goal for Tesla is to stabilize the surface using an elastic ion-conducting polymer coating that could be placed in a scalable manner. This is significantly more straightforward than current processes, enabling a higher proportion of silicon to be employed in the cells. As a result, the cell is less expensive and has a bigger capacity. This will give Tesla the ability to expand the range of its vehicles by 20%. The cherry on top is that the cells are also less expensive. At the battery pack level, that's another 5% cost reduction. If this seems like the ideal win-win situation, you're correct. This is only one of the numerous reasons this battery will set Tesla apart from its EV competition. Reimagining cathode production. According to Tesla, today's cathode production procedures rely on historical chemistries and techniques created in silos. To minimize waste and cost, Tesla developed a plan to optimize each stage from ore to cathode. The simplified pictogram of an exceedingly sophisticated worldwide supply chain, stretching from raw ore processing to delivery of the final cathode, is significantly less complicated. It is not only more streamlined, but it is also significantly less expensive and produces far less waste. Tesla's new high-nickel cathodes do away with the requirement for cobalt entirely. Cobalt is an excellent anchor for a cathode chemically, but it has some major drawbacks. Right off the bat, cobalt is toxic. The less harmful resources that humans mine, process, and utilize, the better. Because the great majority of cobalt production in the world comes from a single country, the Democratic Republic of the Congo, securing a sustainable source of cobalt is also incredibly difficult. The country's leadership has not been the most stable, and pouring hundreds of millions of dollars into an already corrupt system isn't helping problems. Prices have become unstable due to electric automobiles and consumer products, putting even more strain on an already stressed system. Some human rights organizations use the term conflict cobalt to describe how ethics might often fall by the wayside. When all of these aspects are considered, cobalt, while advantageous in the battery cell, is far from beneficial to a corporation aiming to increase battery manufacturing to 3 terawatt-hours per year by 2030. On a cost per kilowatt-hour basis, ditching cobalt in favor of a high-nickel cathode reduces the cost of a cathode by 15%. That's enormous! Tesla's ability to design and manufacture cathodes from the ground up also gives it a leg up on the competition in developing its own internal battery recycling techniques. Overall, Tesla's work on cathodes resulted in a procedure that reduces the cost of producing a cathode by 76%. This is accomplished with significantly less equipment, resulting in a 66% reduction in cathode capital costs. The new procedure utilizes considerably less water than traditional processing, which is the cherry on top. In fact, the new method produces no wastewater. All of these advancements are being rolled into a new cathode production plant in North America by Tesla. It will reduce non-value-added travel in the region for raw materials and intermediary goods. Thermal characteristics have been improved. The improvement that does a lot of the heavy lifting to enable using a larger form factor is the tabless design. The internal resistance within the cell produced by the extra component is reduced by removing the tabs. Internal resistance means more heat is generated, a more complicated production process, and a higher price. Tesla's new 4680 cell does away with the internal tab in favor of integrating the tab's function into the jelly roll itself, giving the cell's end a clean, uniform appearance. Tesla's SVP, Drew Baglino, said, "We basically took the existing foils, laser powdered them, and enabled dozens of connections into the active material through this shingled spiral. The temperature problem is removed from the equation when the tab on each cell is removed, allowing Tesla to go to the absolutely cheapest form factor and the simplest manufacturing process." Focusing on the thermal benefits of Tesla's new 4680 cell's tabless design, the new design allows larger diameter cells to attain thermal characteristics equivalent to smaller cells. To put it another way, they stay as cool as smaller cells, enabling Tesla to cram more power into the same physical volume. Larger tab cells have traditionally struggled to dissipate heat at high charging rates. Tesla's new cell bucks the trend, charging nearly as quickly as a smaller cell, while providing all of the advantages of a larger cell. Tesla was able to combine the best of both worlds, utterly disrupting the modest but expanding car battery cell manufacturing industry. Overall, Tesla's redesign of the battery, cathode, and vehicle chassis is predicted to lower Tesla's cost per kilowatt hour by 56%. This is a game changer for Tesla, and will pave the way for a new generation of low-cost electric vehicles. The basic battery cell is where it all begins. Tesla has made great progress in redesigning the battery cell and is on the verge of mass-producing these new cells. What are your thoughts on Tesla's new battery? Let us know in the comment section below. Thanks for watching, fellow tech fanatics. Before you go and watch another video, make sure to smash the like button for the YouTube algorithm. See you on the next one.